Okay, so let me review vectors with this medium difficulty kind of problem, okay? It shouldn't be hard, but if you don't use vectors the right way, you can make it longer harder than it needs to be. So let me show you an important idea of vectors to make these kind of problems easier, okay? So let's start off and label some forces here. Okay, so they say, what is the force of 50 pounds at 40 degrees? That's going to be my blue vector, okay? The other one I'll make pink, second force is 75 pounds at 100 degrees. Okay, so I'm going to go ahead and start drawing these two vectors on two separate planes. 50 pounds at 40 degrees, then in that case, it'll point the first quadrant like that, where that's 40 degrees. Okay, we'll call this 0 degrees. All right. I'll just call this, I don't know, force 1 then. Okay, which is actually 50 pounds. And the other one, 70 pounds at 100 degrees, well, that's going to be pointing in the second quadrant, okay? And this angle will be 100 degrees, all right? Okay, so find the magnitude and direction of the resultant force, okay? Before we do that, I'm going to show you a really important idea about vectors right now, okay? And this is the way you should be doing vector problems like these ones to make your life easier. Any vector can be broken down into vertical and horizontal components. Choose the right color here, okay? So that diagonal arrow will have horizontal and vertical parts to it, to the components. You'll notice that the shape that you get is a right triangle. So you can use right triangle trig to break down that vector. So I'm going to blow it up right now. I'm going to kind of zoom in on that triangle we have and label some parts. And we'll actually work out some trig to see a pattern happening here, okay? So remember, force 1 was 50 and the angle is 40 degrees, okay? Now, you can get the horizontal and vertical parts by doing trig. So I'm going to call this X. Hold on a second. Orange. And purple will be Y. So to solve for X, if you're working on the trig, you use SOHCAHTOA so that the size that's close to 40, that side is adjacent over hypotenuse. Okay. And so you'd be using cosine for the trig function, okay? And the size you're working with will be x over 50 for the hypotenuse, okay? If you want to solve for x now, you just multiply 50 on both sides. So x equals 50 cosine 40, okay? So I'm going to go ahead and label that expression here. And for the y, well, y is opposite of 40 degrees, so that's the opposite side. As over the hypotenuse, which is still 50. So let's label that. Opposite side is y over 50. Opposite of hypotenuse, we're going to use the sine relationship. So sine 40. So again, you're also going to multiply by 50 to solve for y. Okay, so that will be the expression for the vertical component. Okay, so in general, all right, here's a key idea. In general, any vector can be broken down into vertical and horizontal components. Okay, just remember that for the horizontal, that has to do with cosine. Okay, for the vertical, that has to do with sine. And so if you remember, one of the basics of vectors is to be able to write it in component form, okay? And so we can write force 1 like so. So in terms of i's and j's, 50 cosine 40i plus 50 sine 40j, where the I has to do with the horizontal component and the j has to do with the vertical, okay? So any vector will follow this pattern. All right, remember cosine is horizontal, sine is vertical, okay? So if you look at our second vector, you can break this one down pretty easily now that you know the same pattern. Okay. is the magnitude or the force, cosine for the horizontal, and then the angle, the direction that they give you, okay? Vertical, same thing. This time it would be sine instead. Yeah, I know this doesn't fit the right triangle, like this is not actually 100 degrees, but technically if you type cosine 100, sine 100, it's the same thing as telling the calculator to solve for 8-degree angle, okay, the second quadrant. All right, so the calculator will do the work for you after we set it up and type it in the calculator, okay? So now with these two expressions, then you can set up the second force in that same way as well. So it was 75 cosine 100 I plus 75 sine 100 j, okay? So remember, the point of this problem is to find the resultant vector, and the resultant vector will be the sum of these two forces, okay? And we're going to came up with expressions for these two forces, all right? So we're going to end up adding these two together. So if once you write it like this, the rest is calculator work, and you can add the i's together, collect like terms, and the j's together, and collect those like terms, okay? Well, I don't have a different color for this one. Okay, so I already typed it in the calculator, save time. 50 cosine 40 plus 75 cosine 100 is about 25.28. Add that in. Okay, so this will be the resultant vector, or the component form for the resultant vector. I'll do it for j as well. This will be the vertical component. It's about 106, very close. I'm just gonna call it that. Okay. Now you have that, then you can find all that they're looking for, which is the magnitude and direction. Magnitude, as you know, is basically Pythagorean Theorem, okay? Because what we have here is a new vector where you can draw a new triangle. Okay, so if it's 25.28, 106, so it's to the left about 25 and upward 106. So leave it like that with my new vector. And again, you can come up with a new triangle, which means you can use Pythagorean Theorem, okay? So the magnitude of f1 plus f2. So I type that in as well. It's about 108.97. And the direction, okay, we're looking for the angle theta here. Remember, we have the vertical and horizontal component. Vertical is 106, horizontal is 25.28, which means you can set this up as a tangent problem. Tangent theta equals opposite over adjacent. Opposite is 106 over 25.28, which is adjacent. So you just take an inverse tangent on both sides. And that will be, what is that? 76.59. Okay, so this is a basic vector skill. The idea is to break it down into horizontal vector component form. Cosine has to do with horizontal, sine with vertical. Okay, doing that pattern, you'll break it down every time, where you don't even need to draw a picture, really. Okay, yeah, so hopefully you can do that more efficiently. Definitely do more practice to see more of these. Okay, bye-bye.